I let the stage to Wallace. Please, a big applause to him. Thank you.
Well, hello and good afternoon. Very happy and excited to be here and speak in Rome to a group of .NET developers, architects, I know the program managers maybe even. This session is about the .NET configuration system and all the mystery and the complicated things, but also how can you use this and how can you use it in a secure way and why would you use it? So a quick word to the sponsors. I'm sure you've seen them around with in the hallway as well. I do want to say that the demos that I'll be showing, there's quite a bit of demos. The source code for that is available on GitHub. So if you just remember my name, and then there's a bunch of repos there, but this code is also there. All right, let's not waste any time. Usually they say start with the why. Why would you want to do configuration? Well, apparently that doesn't really help you, right? If you hard code stuff, and there's even a definition that you can find on the internet, that it's not that convenient if you put stuff into your source code that is then baked in, and if you would want to change it, you would have to build the code again and redeploy. So we want to have something that we can change and tweak while we have the code compiled and deployed. All right, so I'm assuming that most of you at this .NET conference are already very familiar with .NET and configuration, so you must have seen this. But let's go through a few basics, and then we'll get into the advanced stuff as quickly as possible. All right, so let's start with a demo. And for that demo, I picked something different than the regular web applications that you would normally see. And in this case, I have a .NET program with this entry point here, the main, that uses the default building of a hosted builder, but it's using a hosted service. So this is a background service that we're using, and this background worker has some configuration values that it needs. And this is just a demo, right? So it's simple scenario. On the start of our worker, so this is the worker, what we do is we inject this I configuration, and that's available apparently from the dependency injection system. We keep a reference to that, and then during start, and this is similar for all the other demos, we just do a bunch of logging for a couple of values. So there's a welcome text, a delay, which is a value as an integer, and there's this thing, the admin password, which obviously later on we want to protect. So 3 things, string, integer, and something secret. And then it starts, and it does nothing more than go into a loop. Well, as you can see, if you want to have something like a configuration as a string, you can just read it by using an indexer. That's easy. If you want to read something like a delay in milliseconds, you would have to parse it. Now, well, and these are the easiest ways to get to your configuration data. There is a nicer way to get to a value that is typed. As you can see here, if you do get value of int, the parsing is done for you automatically. And then it just outputs this thing all the time, so we can see what is happening. So I'll just run it once. And as you can see, we have this basic welcome, a delay of 2000 milliseconds, and this no one knows is the secret password apparently. And we will get into, where does it come from, but because you already know and are familiar with this, we know that it's coming from right here, right? App settings JSON. So this is what you know, and let's build on this. All right, so getting to know the configuration system, you must know about this hierarchy. And this hierarchy shows you, the various things that you can have in a key value tree of values. Everything in the tree is called a configuration section. And they can have values, like the ones at the end that are in darker gray. And you can have the ones in black that have only child sections. So it's one or the other. They can have childs or it can have a value. But this is what you'll build using the configuration system, and this is also what you will read. Now you can build this hierarchy all the way through, but you can define a section, a configuration section, that has the hierarchy as in a file path traversing directories, as you can see in the far right. So if you use a colon, that's the same thing. So it doesn't matter if you create childs or just have a single one. It's the same way to define a section with a path to it and a value. Now, reading from this, you can do it in many ways. So just to get us all on the same page, if you do get section on your iConfiguration, you will get an iConfiguration section and you point it to somewhere in the hierarchy. So if you say, I want to get worker, then you'll get this part of the tree. So it's a section with everything underneath. If you would say, I want to get section and then the delay in milliseconds, essentially you're pointing to the worker, to that thing in particular, and then you'll get just this single thing. So you can retrieve it in a number of ways. So worker welcome text, the top one here, that's the path directly. Or if you got the section on the right, you can just say, I want to get this particular value. As we saw the code, you can do get value of integer, which does the typecasting for you and the parsing. Now we also saw where does it come from. So most of the time you'll put it in app settings JSON. That's the obvious one. But there are ways where you can get it from an XML or an ini file. Back to the old days of Windows 3.1 even. It has a similar hierarchy. We'll look into that. And the other place where you will get it by default is from environment variables, and they are prefixed. And the prefix will be removed and you will get a value that is the same as what is behind the prefix. It's either ASP.NET Core if you're doing a web application. It can be a web API or a Razor based or that's it. And in our case, because we're doing a background service, it's .NET _ because there is no ASP.NET Core. But if you start hosting something, either one will work. And you can put them in your startup of the debug section of your Visual Studio project, and you can specify those. And this one is typically specified, but you can change it obviously. And we can put stuff in there that we want to change. And there's also a story about the precedence or the priority of these ways of configuring these. All right, so this is what we just did, right? So we have an iConfiguration, we inject it into the thing, we store it in a variable, and we're good to go. Okay, don't do this. Even if it's possible, this is most likely not the best way to do it, because if you give a class the iConfiguration, you're giving it everything, right? It's maybe even the configuration root, the thing all the way at the top with all the providers that led to this configuration. So you're giving it the keys to the kingdom of configuration. It's better to say, okay, we should maybe extract the values in a typed form. So just to give the values that are particular to this thing, this worker had the 3 settings. We don't need all the other ones about the log levels and what have you. So, even though behind the scenes this is done by the framework itself at singleton iConfiguration, so you could inject it anywhere. Be very careful doing so. It's much better to do binding. And in binding you will say, okay, we've got 3 values, so let's define like a holder of those values. We'll start out with a class, 3 properties that are the integer, the string, and the secret stuff. And then you have 2 typical ways to get to that values and put it in an object, an instance of that class. One is, create an instance and then call, we need to define the section, and we want the section of the worker, which is the worker, so that part of the tree, and then do bind on settings. And it will bind it. So we will start doing this thing. It will start doing, okay, so I match one, I match another one, I match another one, and if it matches, it's okay. If it doesn't match, it skips it. So it's very, very relaxed to get those values in the object. You could also do a get, where you don't have to create the object, but you can just say get me of the generic, and then the type that you want to have, worker settings, again specifying the section that you would want to have. These 2 exist because sometimes you're given an object that is partially configured, and you would say, okay, configure the rest of it, like the secrets, put it in there from our configuration. So you start with an existing object, and this is more convenient if you don't have an object yet. Now, which ones are there by default? We need to get the values from somewhere. And we start with our root, and in your JSON file, you would define in a JSON format, you would define the hierarchy of your configuration. So it mimics this structure. There's two JSON files if you pay close attention to your project. It's app settings JSON, but there's also app settings development.json. So there's two. Now, as you can see, you can override some of the values or add values by layering them on top of each other. So we're adding stuff more and more to the configuration, but you can override existing values and you can add to existing values or parts of a tree. So for example, the user secrets, see how it says at the bottom, admin password is replaced. No, that's just an indication in your JSON file where it says, we need to replace this. We don't want to put it here because if it's there, it will probably go in your Git repo, and then everybody can see it in the history. You're like, oops, and then you revert it, or you have to repair. But it's better to use user secrets, and we'll get to that. But if you define in user secrets just the green part, it will add that to the other one, override the existing one, and so we can start building up everything. So there's environment variables, there's command line arguments that you can pass to your program, and they can all add up to the final configuration. So if they're lower priority is the ones that are at the top because that's where it starts. Your configuration providers that are added later on become more important. So the last one wins. Now there's other ones that exist. You have the ini and XML file thing. You have in memory, if you want to do unit testing, for example, you can build a dictionary and then pass it into this tree structure as well. And for those, and I hope we'll get to the Kubernetes part, but if you do Kubernetes and have a CSI driver, this thing keeper file provider is something you want to look into. We'll talk about Key Vault, we'll talk about app configuration. Those are all there, but you need to include additional NuGet packages and have Azure resources, obviously, to start using those. And if you want to build something yourself, because you read something from an external source, then you could build your own provider by implementing iConfiguration Provider. And there are third-party products out there that will help you do, this externalized stuff that you can get into your application. Now, I thought I'd show you the difference between .NET 5 and .NET 6 because I think it is relevant. It's kind of how they build things. In .NET 5 and before, you would have a configuration builder and you would have a configuration root. Now, the configuration builder has this interface that you can use and you can do add, like add key vault, add in-memory collection. And every time you call that, it adds it all as the sources. So it stacks them up, but it doesn't do anything yet. But only when you call build, it will create this configuration root, which is an object that implements iConfiguration root. We'll use the respective providers for all the sources that were registered, and the providers will read from the sources and populate the configuration data. That's the configuration section tree structures that we saw. And then you can start using it. So the iConfiguration root is nothing more than iConfiguration with the providers added to it. But you need a build. And this is where things sometimes get tricky, because if you have a bit of configuration, like a client ID and a secret, to get to Key Vault, for example, you need your configuration to get more configuration. So you need to build it while you were actually still building it. And that's kind of a problem, that you need to do a partial build. But in .NET 6, they did something new. So they have this thing, not the configuration builder, but the configuration manager. And you can do an add, Key Vault or something, and it will start adding this to the sources internally. But immediately, it will use the provider to start building the configuration data. So this means that whenever you do an add, you can start reading from the configuration straight away. And this is very optimized, I would say, because then you can say, okay, add something from environment variables. I will read client ID secret, and then I'd say add Key Vault, and I can use my configuration to read and get access to the Key Vault. So build doesn't really do anything anymore because it's continuously built. And it's a shame if you need to get rid of everything, because the previous model was more optimized for, I changed my mind and I want to go back. This is building all the time. All right. So let's show a bit of demo here. So just to show what the things that you can do if you want to go a bit beyond the regular. So if you have your default builder, you can say, okay, I want to configure things that are related to the application. There's a hosting part, there's an application part. Application is the configuration you need for your application. Just to demonstrate, you can clear out everything that was added by default and then start building what it is that you think you need. So there could be ini files, XML files, it could be even JSON streams from memory. You can do in-memory collections. You can even pass building a I configuration and then adding to it to the bigger I configuration, so you can all do all this fancy stuff. And then, well, obviously there's the bind that we saw on the slides. And once you've bound something or gotten something with the get, you need to add it as a singleton with worker settings. So you can pick it up in your worker here, where you inject worker settings. No interface needed. You know, the injection doesn't require an interface. You can inject a singleton object just as well. And then you can look at the properties of the settings object, and that's where you go. All right. Now there's this other thing, the options framework. And the option framework extends what we just saw. Now, this option framework, if you first look at it, I've heard this said, it's just a simple wrapper. It doesn't add anything. You know, all it does is, you know, I can do configure and then worker options, which I explicitly named options instead of settings, because this is the options framework. But it's a similar class, 3 properties for our worker. And we give it the configuration or the configuration section that it needs to read from. But if you want to use it, every time you need to use it, you need to do .value, so because it's indirect. And it's if this is it, why would I use this, right? So the options framework doesn't seem really useful if you look at it from this. Just like, you know, you're looking at the fish and like, oh, okay, cute fish, but that's not that special. But in second glance, there's all these cool features, so there's much more, where you can say, okay, I can configure from dependencies. I can defer the evaluation with that .value, so I can do stuff that might change the outcome of the actual value that is being read. And you can do post-configuration, because as you'll find that if there's configuration being added from multiple places, the last one wins becomes a thing. And if you're a library builder and you want to have the final say in the configuration, checking stuff, validating things, then you would need this post-configuration that you can use. Now then there's the options builder, which is the thing that can build the settings and the configuration from options. And it starts with add options, but once you get down that path, you can do validation of values. You can have named options to keep track of bundles of things that are particular to, for example, a feature that might have similar properties, but 2 separate features, 2 things. Yeah, and you can even extract the logic that does the post configuration or validation into a separate class. So this starts turning into something really nice. Let's have a quick look. All right, so I'll just make sure that we have this. All right, so in our program, so this is another nice thing. We can say, okay, I want to get this section, but it should be there. So get required section. That's new in .NET 6. Well, this is the easy part. Configure worker options for the section that we just got. And I'd use this name of worker. So I get this string of worker, which should be here as in worker. So I get this part here. And then I can use the worker options, which is just a class. But now you see there's all these attributes on top of it. So this is from the data annotations. And this says, okay, things are required, things have a valid range. So all of a sudden we can start checking if these options that somebody that configures the application starts using, if they're even, you know, valid. Okay, so here we go then. then this does the default thing. This is the easy part. I put it in there, but if you want to go more fancy, you can say, okay, add options. That's where I said, this is where you can get started. And then you can say, I want to bind, but I want to set properties for the binding. How does it behave? So if it encounters unknown configuration, it should error out. Like this setting that you're setting doesn't make sense, so stop. And you can bind to non-public properties as well, where you can, to internals, for example. That's also possible if you wanted to. You can do validate data annotations. Those were the required and the ranges. You can say, okay, validate those for me. And I put in something, just as an example, a popular password checker that does some logic to check something. In this case, this password checker just checks, is somebody using a popular password? If the string equals easy, then we're saying, okay, that's. But just imagine calling out to this, what is it? I've been owned, the site where you can see known passwords, for example. You could do checks there, for example. Just make up something on validation, but it could also be business logic on the configuration. Well, with these things, let's run it first and then see what happens. Because I see that there's a thing there. If in the worker we start using the value, but see how I try catch this in a options validation. And you can see that I just log all the exceptions that or the failures that were found in the validation. So we start running. So I'll just do this to stop it from going further. Let's see if I can zoom in a little bit. No, it doesn't work. All right, but I hope you can see that it says data, the validation failed because the delay in milliseconds, I believe it's 100. So let's quickly check that. See, it's 100 and it should be between 500 and 10,000. So that's not a valid range. But you can also see that this thing here is continuing to run, right? We caught the exception, all good, but this might not be what you want. It might be that you want to be very defensive and do something like this. So you would say this is new in .NET 6 again, so this is not in 5 if you're still there. But if you do validate on start, then immediately your program won't even start because it has an invalid configuration. And if you go to the details, and you can see the message here, you can see that it says that this is not within the range between 500 and 10,000, and the admin password is common because we also had this thing easy here, right? So it actually picked up on the thing, like 2 things were not okay, and we don't even start. This is good because then you get alerts and something is up, instead of during runtime, where there might be even a security misconfiguration, for example. So this is being defensive. All right. Now, one of the things, if you start building your code, packaging it, it could be a zip file for web deploy, it could be a container image, and you start pushing it out, you might go through different environments. So your code stays the same, the configuration changes based on your environment. Well, I like the picture now that this is where we do development or pre-production. It's like this is what we have to deal with. Low load, moderate settings maybe for caches or other things. But if you go into production, whoa, now we get the big stuff, so we might need to tweak things there as well. It could be connection details, the final production APIs that we're calling to. It might be connection strings, and then it might also contain sensitive data once we go into production. So these things that change, we want to deal with them. And we can do so with the built-in support for that with iHosting environments, which gives you an environment name that can be anything that you want, but there's a few predefined ones. Developer, development, staging, production. And there's even extension methods that allow you to check is production, is development, and you can build logic on top of that. There's this other thing, and this is like a hidden gem, I think, that's called convention-based startup. If you start the ASP.NET Core application slightly different, it will look for specific methods in your startup class that have the name of your environment in them. So for example, you could have not just the configure services, but you could have configure staging, configure staging services, and the same for configure production services. So this I'll show you in a demo in a bit. Setting the environment is done through an environment variable or any other way that the configuration system offers you. But typically, an environment variable sets the environment, which is something different. But there's other ways of doing it. You can do it in code. So there's an extension method on your builder. You can configure it through the web host defaults with use setting, or even there's an overload that you can use. But again, there's this enumeration or this static strings, environments.production, but it can be anything. If you want to do UAT or QA for quality assurance, you can pick those as well. All right. Now the other thing in your environment is you want to keep out the secrets as much as possible. And during development, if that's your environment, you can use the feature that's called user secrets. It's in Visual Studio by right-clicking on your project. It's also available in Visual Studio Code. But essentially, what you'll do is you'll look at what is sensitive data. It's this welcome text and it's the app config. We want to get those out. So we create a different file, secrets.json. We put those in there, and they go out of the other side. And this will again add to each other in the layering that we saw a while back. But remember, this is only for development scenarios, so that this is not something you would want to use because the secrets.json still needs to be somewhere. And it might not be in your root of your source code, but if you need it and needs to be loaded, it's lingering around somewhere. Somewhere is there. So if you want to look it up, then you'll find it there. This is some details. The slides are available, but even if you don't have Visual Studio 2022, you can still do it from the command line or from Visual Studio Code. So there's ways of interacting. For example, from the .NET command line, it's user secrets, and then you can set and list them. And you can even set some properties that allows you to specify what the user secrets ID, so the name and which then specifies the location at the bottom right. You can use that to specify that and tweak it. Now for Azure Key Vault, that's a really nice place to store all your secrets, especially in pre-production and production, because it's dedicated to that. There's HashiCorp Vault, there's from AWS, there's also a vault. I haven't used them myself, but same thing, right? They would have providers to allow you to connect to those. What would you do? Well, it's the add Azure Key Vault. Add a provider and add it as one of the last, so you can use all the other configuration to tweak it. And in this case, we need something like credentials to get into it. And if you use Azure Key Vault, you can't use a colon, so the two dots to do the hierarchy. Instead, you need to do two dashes. So worker -- delay milliseconds is the name of the secret, and then you can give it a value. Now, these credentials that are in the first line, it says, the Vault URI credential. That credentials you can get, the best way is by using a managed identity in Azure. That means that there are no passwords. It's just an identity of the service, which could be your app service, calling into Azure Key Vault. No secrets required. If you're not there yet, or if it's impossible, then you can get your credentials from configuration. So this is what you would do. I've tried binding it, but it seems that the client secret credential doesn't have the requirements for binding or getting it. So you would need to read them individually, the client ID and the secret and the tenant ID of your Azure Active Directory. Now another thing is because settings usually are immutable, you can use the record type instead of a class, do a getter and an init. And this is a better way of making sure that it doesn't change. So we can validate at the start, we get rid of our secrets, we externalize those, and we make sure that while we pass settings around our application, nobody says, change something in the delay milliseconds. That would be a configuration change. All right. So in the startup, what you would typically do, and this piece of code uses the default builder, so that's the configuration builder, and this is where you need to build this partial config, because you need to get into the section that defines the everything on the key vault. So that's in my user secrets. So if I would click here and say manage user secrets, we would go into the secrets JSON file. Well, if it's there and it's not empty and we find this URI, then we can say, okay, normally this would be the single line for managed site entities, but otherwise we will build a client secret credential and then set, initialize the secret client, add Azure Key Vault, and everything will work, right? Now that's about what you will need to get everything running, because now we can do this I options that we inject, and we can read everything from there. Now there's this other thing that I didn't show you before, but for demo purposes, and this might also be for debugging purposes, we get hold of the I configuration, and this is something that well, let's just do this like so. Let's experiment a little bit. Yep, that was the old project. Just a second. All right, so if we look at this configuration, it's kind of hard to see what is all in there. You need to really drill down. Now, if you use this thing here, let me see where it is. Get debug view. You could go into the immediate window there, and you could say configuration. Let's hope this works. All right, so it's a bit hard to read, but this is a dump of all the values that are in there. If you would print this, because there's carriage return line spaces carriage returns new lines in there, you will get a nice layout of all the things that are in there and where they came from. So this is nice for finding out, why do we get the wrong configuration value here? Oh, there's some other provider that overrides it. All right, so we start doing it. And this is what you will get if you do a nice printout. So it gives you all these things. There's a lot there because those are all the environment variables. But you also see that this connection string and the instrumentation key have this star, star, star. So they are not displayed. And that's what the little bit of code here does. It checks if there's certain configuration providers that we shouldn't print, but print stars instead of the value. So you can be a bit more secure if you do a dump of this. All right. In the interest of time, I'll move on. The other thing that I wanted to show is if you have your application running and it's up for a long time, could you do configuration changes while it's running without stopping it and starting it again? Well, it's possible. There's four different options per provider. If you look at the files, they have a reload on change. For Key Vault, you would have a reload interval, which, a period in which it's being refreshed if it has changed. And in app configuration, there's a way to expire your cache, so it fetches it again. You can get a change token object on a change, but you need to get, for example, a reload token for a particular section. So you would say, okay, I want to watch this section. If that changes, and it depends on the configurations provided that are there, if they can signal, no, I provided this, but now it has changed. And if so, the state lambda, where it says debug write line, is your bit of code. What do you want to do to change this configuration value? The other thing, if you want to have refreshes, it needs to be externalized, your configuration. Can't be part of the files, for example, because these are deployed with your application. But Azure App Configuration is an example of something that is external, where you can change the values from the outside. And again, it says add Azure App Configuration in the code, where you give it a connection string and then say how you want to select. And one nice way of selecting is by saying select per environment, because I want to have different configuration for development, production, testing, staging. Now inside of Azure App Configuration, you have this Explorer. This is a bit bigger, where you can say, okay, I have all these values that are there. Some might come from Azure Key Vault, so you can reference something existing in Azure Key Vault. And you have the delay milliseconds, the worker, the welcome text, and a sentinel key. And the sentinel key is used, so it doesn't have to monitor each of the values, but if the sentinel key changes, it knows I have to reload the configuration. So that's a signal key. And that's the one that references the key vault. Now, if you use the normal configuration system, you would have the I options, which is a singleton. So you get a singleton and it changes, and it doesn't ever change, even though your configuration values might have changed. So there's two other ones, the snapshot and the monitor, that allow you to have different scopes. The snapshot is typically for a web request, where at the start of the web request you get a value from configuration, and it doesn't change throughout the life of the request. But the I options monitor is the fanciest one. That can really, monitor changes in values. And for our background worker, that's an ideal fit. All right, so let's have a quick look at that one, and then we're out of time. All right. All right, so our program, what it does, it says, we need to get the connection string. The connection string lives somewhere. It's in our user secrets. There's the thing, and it has some secrets at the end. This is where the secret starts. And we want to use that. And there are some values in here. Welcome to the app settings JSON. That's if it would come from app settings. But we wire up the Azure App Configuration, and we say, we want to select any key, but based on the environment name. And then we have the Sentinel with a cache expiration that we can signal. Now, let's just run this. There's some other things while it starts. There's this change token. This change token here that allows us to change something, and we would also see it. And we have this refresher that we got from the Azure App Configuration, but we need a bit of middleware to do it per web request to change to check automatically on each web request if we are using ASP.NET Core. But we are not using ASP.NET Core, so we have to do it ourselves, which means that inside of our loop of work, we have to try to refresh it ourselves, which means it looks at the Sentinel key. Is it changed? Nope, then it's good. Yes, then we will reload. Now, in the meantime, we had this all running. So we saw that there's the hello from the development config, not from app settings JSON. Where did this value come from? It came from, let me see, the app configuration here. So this is Azure App Configuration. I'm in the Configuration Explorer, and it has the settings for worker, delay milliseconds, and for the welcome text. But it has different values for the typical environments, development and production. So if we look at this one, welcome text here, and we would change it. So we would say something like this, and we would say apply. Now it is a bit slow because it doesn't immediately change it, but you can see that it's still doing the old value because it wouldn't notice. We need to change the Sentinel key to indicate, make it faster, make it happen now. So this is just change the value. Doesn't really matter. And if we're lucky now, and it might take a few seconds, we could see that it picks up on a new value in a moment. So I'll let this run and just fingers crossed that it does. Oh, there we go. See? So it picks up on those values while we are running, and no need to terminate this thing. All right. Yes, we had 5 minutes, right? So I could do a quick thing on containers. If you've used them, immutable, so everything that's inside can't be used. User secrets can be mounted during development, not in production. So how do you deal with that? Well, you pass it environment variables. That's the way you push the configuration in that needs to be changed. But how do you get the environment variables into your application? Well, this is more about Kubernetes and how Docker Compose works. But for Kubernetes, you can say, okay, I have environment variables where I use this. And what is important now that it's underscores instead of dashes or a colon. That's how you can pass the environment variables in, and they will be merged just like before, in the layering. The variables are pretty late. A better way of doing it is by using a secret. So you can refer to a secret for the value of your environment value, which is how you would create that is on the right side. So you do the base 64 encoded thing, pass that in as the admin password, and that's where you can refer to this key that matches up on the right. So if you push that secret in, you can get the you can read those variables in a safe way. And there's another way where you can just do a JSON settings file and create a secret. It is the complete file with your JSON settings. So if you have multiple, push those in as a secret that is a file, and you can add a JSON file mounted inside of your code in your runtime environment in Kubernetes. Say it's optional because it might not be there. And then you just like your app settings development.json, except it's now app settings.secrets.json. All right. So that's kind of the easy part, getting that to run. Let me show you for Docker Compose. If you have Docker Compose, in your override, you can set environment variables like so, 5000, hello from Docker Compose. If you run this Docker Compose, it should be ready in a moment. As you can see, we've changed this thing to, just watch for this one. There we go. If we now go into containers, look at this one, look at the logs, go all the way up. We can see all the dump, and we can see that it's hello from Compose override. So you can see how you can push those values in as well. And if you do the other thing with the JSON files, you can even tokenize those in your pipeline, then set it as a secret, and nobody knows about the contents of the file. All right, that's it. I hope that you got a good feeling of what is all there. I'll be around for the rest of the conference to answer any questions. I believe we're out of time now, so questions we'll take afterwards. But thanks very much. If you have any questions, send me a DM on Twitter or a message on email, and thank you very much.
Se avete qualche domanda potete farla, Se serve un traduttore c'è lui. If they have any question, you can take some minutes to answer.
Questions then?
Question?
Yes.
We talked about layering of configuration, so if we replace property in the properties release, but what's the behavior when we use an array? Is it merged? Is it replaced completely?
All right, yes, that's the good question. So the question is, these were all single values, but you can do arrays, a list of URIs, for example. I don't know the exact answer because it depends on how it's done and when. But it's difficult. You can replace individual values into an entire array or replace it. But I would have to look it up because I've not run into it in real life. But I do know that both scenarios are possible, replace the array or replace single items in the array.